First of all, I just want to say thank you to Martha for finding me. I am a Stanford alum. I was here many years ago with the engineering department that was then called industrial engineering, so that was how long ago it was. And since then, I've been working in technology companies all over the Bay Area and have loved that process of introducing and building new technologies. And in that time, I started to work with financial organizations like Swift. How many of you have heard of Swift or worked with Swift? Okay, so quite a few of you. So in the 2008 crisis, it was very clear, which is when I was working at Swift, and even before then, that our financial system needs to change. It's broken. And there are alternatives. So when I finally understood what the blockchain was about, and by no means does it only apply to financial services, it really made sense to me, and it really made me think about how we could change the world with this technology. So this is, just to give you a little background, where my day in, day out is like. I work with thousands of, or our company has thousands of different companies that use blockchain technology, use our blockchain, web services, and infrastructure to build new blockchain applications. And so I've talked to a number of you in the last few hours about some of these applications. One of them was with a gentleman from Nissan about supply chain and how the blockchain could be used in supply chain scenarios. We've also talked about earlier this morning, a gentleman from Vobel about the use of the blockchain for media content and verifying media content. In both of those cases, what you have is a complex process and a lot of players who use data. And because of the proliferation of devices and how we communicate, this data becomes entangled in a web of different relationships. It's touched by many different people. And it becomes hard to identify, to authenticate, to verify that that piece of data came from this person or that device. And this is where the blockchain is very powerful. Traditionally, if you're in a supply chain process or you're in the business of managing data, you may be sending spreadsheets around. And how many have done that? How many have sent spreadsheets around to manage the data in them? Okay, yeah, so very error prone. At any point, somebody else could come in, take that spreadsheet, make changes, and then you've got something else there that shouldn't be there. Now, the blockchain helps address that because of its inherent security, its transparency, and its immutability. Now, what we do is work with a number of companies in a variety of use cases. I talked about a few of them. I encourage you in any industry, if you're interested in hearing about how the blockchain may be applied in your use cases, in your world, please come talk to me afterward. I'm always excited to talk about how we've been working with different companies and how we might be able to help new industries. And so fundamentally, what we do at BlockCypher, so you can hear some of why we're involved so deeply in these blockchain projects, is that we're this middleware and infrastructure piece. So basically, we connect these applications to all different types of blockchains. And that's really important to note because from the beginning, our company has believed that there isn't just going to be one blockchain. There are going to be multiple blockchains. And each of these blockchains has a specific use case or set of use cases that they are good for. And that's important because the technology for these blockchains, the fundamental technology, the differentiation that these technologies have, leads to some important differences and reasons why you should choose one blockchain over another given the use case. Here are some of the web services that our companies use. Our customers use to quickly get started and building new blockchain applications. So I just wanted to pause here for a second and just get a show of hands from the room. How many of you have heard about blockchains before? Okay, most of you. How many of you have spent a lot of time and would say you're an expert in blockchains? Okay. Okay. Okay, well, so for that, I'll go somewhere in between. So maybe I'll just spend a quick overview since most of you heard about the blockchain, which is great. So I'll just highlight some of the quick reasons why the blockchain, or what it is, and then the reasons why it's so important. So first of all, if we just take a step back, right, the blockchain is fundamentally a database. It's a distributed database. So instead of in your traditional world or what we have today, where we have one database, we put all our, say, customer information in it or all our identity information in it, you now have a distributed environment. Now, why is this important? Well, if you look at the recent Equifax hack, how many of you were affected by the Equifax hack? Okay, so a few of you, great. I was, so I'm always personally interested in this part. So in the Equifax hack, like many hacks, whether they're at hospitals or universities, there's a central database that a hacker has figured out how to get into. And that's not always that hard. And for a lot of them, it's actually quite easy. So that's a problem, right? Because then you have all these centralized databases that are now easier to get into, causing a lot of problems for the rest of us. Now with the blockchain, you have much higher, much enhanced security. And you also have now a way of achieving consensus, meaning you have a way of adding data to the blockchain that is different. And that's important because this process of adding data to the blockchain is much more secure. Instead of having one centralized place for a hacker to go to break into and basically steal our information, this hacker would have to go to many different systems where this information resides and somehow hack into all of them at the same time and basically screw up the data. So with the blockchain, because of these innovations that they bring, the security, the transparency, the immutability, and this new way of achieving consensus, you have many organizations, starting with the financial organizations, that have said, you know, this is going to impact $3.6 trillion of our economy. It'll save banks $22 billion. It'll save consumers $16 billion. But if we go back to why is this important, it's first because of this ability to add that data, these decentralized transactions, and that is now enabling much faster settlement, elimination of third parties that don't need to be involved in this process, and lowering the cost overall of doing transactions, of exchanging value. The second biggest reason and why the blockchain is so valuable is because of its transparency. So we talked earlier about the supply chain use cases, where you have people who need to track data or who need to see data from all different parts of the world at all different parts of the process. And this is where the blockchain, because everybody has the same copy, now has that same access to the data, which is now completely transparent. And the third reason that we talked about is the security. So with the built-in cryptography and the enhanced capabilities that brings, now we have a much more secure way of storing data. So this talk, I wanted to shift now to not just what is the blockchain, but really why you should be building, or why a platform, a behavioral analytics platform built on the blockchain is important, or built using blockchain data is important. First of all, you've probably seen this explosion of data. There have been a number of blockchains that have come about over the last year or two. You've seen increased regulation because of that. But what I want to spend more time on is the blockchain data complexity. Why is blockchain data complex? And if we start off with, there's a few characteristics. First, you have the notion of addresses. And addresses are really like accounts. They represent entities. And what's powerful is that whoever owns this account, whoever this owns entity, is the only holder of a private key, which then makes that person the only person who can unlock that piece of information. Now, the second area that I'd like to touch on is, now, while that notion of an account seems simple, and while this lends itself to pseudonymity, which for a lot of people is kind of scary, like the DHS, the US Department of Homeland Security, who we worked with, this seems kind of scary. You can actually, and I'll show you later, you can actually figure out by using behavior analytics who these entities are, or who the type of these entities are. Now, The second area that kind of is complex about the data within the blockchain is that there may seem to be no relationship between addresses. So there's these things called hierarchical deterministic wallets. Now what this means is you're able to create a number of addresses that are related to one address, and to an outside observer, you can't tell what the relationship is. That again confuses people and then makes people think, well, how do I know who's who and how do I track things? What further complicates things is that there are multiple blockchains. Now we talked about this before. You have multiple blockchains that have evolved and they've been developed for different reasons. Some blockchains are more well-suited or better designed for frequent payments. How many of you use FedWire? How many use a wire on a regular basis? Okay, some of you. How many of you use ACH, credit card? Okay, so you have multiple payment methods at your disposal, and you use those different payment methods depending on what you're doing, depending on the amount of money you're spending, who you're sending it to, and so forth. The same thing could be said about blockchains, right? In terms of transactions, there are transactions that are used for frequent payments. There are blockchains that are used for frequent payments. There are blockchains that are used as a store of value. There are blockchains that are really designed for contracts and for handling sophisticated logic. So going back to that supply chain example, if we were to elaborate on that, let's say I'm Starbucks, and how many of you had a Starbucks coffee this morning? Okay, none of you. Great, that's because you had the coffee here. So for those of you who did go to Starbucks any other day of the week, you might know or you might not know that the temperature of the food going to Starbucks is really important, right? The eggs that go to Starbucks cannot be above a certain temperature. So it's really important that all along the way, every step of the process from where the eggs or other product comes from the farm all the way to the Starbucks stores near you, that the temperature of those goods has to be tracked. Now, while Starbucks has a device to track the temperature of those goods, Starbucks doesn't necessarily know at all times if those devices have been tampered with or not. Right? How do you ensure that? And how do you know that the data coming from that device has also not been tampered with? So these are the types of things that you can now track with the blockchain. You can audit and say, all right, this is happening, this has happened, and therefore, based on a contract that I also can encode on the blockchain, because the temperature of the eggs has been this degree the entire time of the journey, I will pay that supplier the full amount that we agreed to. And that can be automated. Now, in that process, what you can now take out is the risk of having the device tampered with or any part of the process tampered with. So dealing with, say, I don't know if you could call it counterfeit eggs, but damaged eggs. You can take out middlemen or middle people in the process, who may have been needed to inspect, the state of the eggs all along that process, and also take out unnecessary people on either end who have to receive the goods and qualify that the contract requirements have been met. So if we look at going back to the analytics and the data now that we have on the blockchain, what we found is that there are a lot of tools, but these tools really don't, when you look for fraud specifically, as an example, these tools don't have the ability to go beyond the sort of manual heuristics that have traditionally been used. And what we found in developing a blockchain analytics solution when trying to uncover fraud or other issues is that you need a combination of strategies, whether it's using structured queries, hand-tuned heuristics, graph traversal, and machine learning. So if we go back to our example on identifying fraud or counterfeit activity in our supply chain example, right? So you have some supplier who has been sending goods through to Starbucks. How do you know that these goods have been tampered with or not? How can you identify through the flow of transactions if someone who is paying for these goods has also been doing some illicit activity elsewhere? Now, this is where, with the blockchain analytics, you could start to identify behavioral patterns, because the blockchain captures all this data, right? Every point in that process, every point in the supply chain process, every point in a monetary transaction is captured. So if we now shift gears from looking at a supply chain scenario and looking at a financial scenario, right? And you have money, say, coming from here to say your friend in Russia, right? And then that friend in Russia sends money someplace else. How do you know, or how do you follow that flow of transactions? If you were dealing in cash, you wouldn't know, right? All that information would be gone. But with the blockchain, you've captured that data. You know when each transaction has occurred, you know for how much, and you even know where, because that is information we can derive. Now, if we look at blockchain transactions, because blockchains are like networks, you can start to see how you can take graphs to really represent behavior and begin to see patterns. So in this example here, and this is really looking at a financial transaction, you could see that there's a center, clearly, of activity, and that it goes out from there. And in this example, this is a mining pool, and these are all the recipients, of the funds from this mining pool, all the little dots on the outside. So you can start to see behaviors in these different transactions. This is another example of behaviors. This is a graph of monetary transactions, and use this information, using these types of tools and this data, you can now track where transactions are coming from, where they're going to, how they behave on a regular basis, and start to label these transactions as coming from certain types of entities versus others. So where this is important, going back to financial analysis and really the forensics world, I'll give you I'll talk a little bit more about now our work with the U.S. Department of Homeland Security. So for the U.S. Department of Homeland Security, catching who the bad guys are is really important, and what the bad guys use on any network is very important. And so how many of you, when you first started hearing about Bitcoin, were like, oh, that's bad, dark web? How many of you had that impression? Okay, some of you are chuckling, okay. So U.S. Department of Homeland Security was no different. They wanted to find out where the root of all these transactions were coming from, and find out if indeed, these transactions, certain transactions, were coming from the dark web or other places that should be monitored. So this is where we started working with them on tracing these different monetary transactions and finding out that there are different patterns belonging to, say, ransomware versus gamblers and other types that you should be watching out for. And so this process called labeling enables them, but also enables others to say, look, these set of transactions are good. These are going through merchants that we know, exchanges that we know, processes that we know, and these transactions are going through ones that we don't know as well. And so that process has enabled us to also dig deeper and find the sources of hacks and of heists. So this is an example of a hack at an exchange, the Bitfinex exchange. So using our tools, we were able to start identifying that there was an unusual pattern. and a usual pattern of activity. And with that, that sort of indicator, we delved deeper and found that there was a heist going on, and that the inputs of this transaction all had this similar pattern where some of them were going to, obviously, this address here that was owned by the hacker, and then a separate part was going to BitGo, which is a company that's used to ensure these types of transactions. So using the tools that we have and using the analytics and the machine learning capabilities that we have, we were able to identify the addresses, and these are IP addresses, corresponding to the blockchain addresses for the hacker and the amounts that were transferred. So that, what I just showed you, was an example of how we're able to help an institution, an agency like the US Department of Homeland Security identify where the source of a hack or a threat was. Now I'm going to switch gears and talk just in the few minutes that we have left on how you can use blockchain analytics to really understand financial growth. And this is where using the same set of blockchain data, you can now understand where this blockchain activity is occurring in different parts of the world. Now this is taken at a certain point in time, but you can start to see where the concentrations of activity are. And then if you were to time series this, you can now see overlaid on this map where activity is occurring and start to draw different relationships. So this is really important for companies that, say, have their own blockchains. And they want to understand where activity is happening because it's this distributed network. It's difficult to find that information, but using this type of data, you're able to see, all right, I can see where pockets of activity are occurring. And you can also see whether actions that a company makes lead to results in that activity. So for example, if the company is doing a promotion in, say, Brazil, you would hope to see some more activity over there. And because you're monitoring this kind of transactional activity over time, you'll be able to see that pocket light up in color. And so we've been able to do this for a number of companies that we work with, really use this kind of blockchain data to highlight whether or not promotions, different things that the company is doing actually affect transactional activity on the network. So thank you for your time today. Again, I'm trying to share just a few of the examples that we've been working on with different companies. Besides the US Department of Homeland Security, we're working with the US Department of Energy and a number of banks, financial institutions, as well as enterprises, whether it's companies working for using for supply chain use cases. We also work with healthcare companies. So we'd love to hear about your interest in using the blockchain, and if there's something that I can share with you, any information I can provide. So thank you.